Okay, this is exam 2 for spring 19 for physics 151. Number 1, a softball player catches a ball and brings it to rest. So I have this ball that's going in this direction, and my softball player's, her glove is right here. She's going to exert a force in this direction while the ball has a displacement in this direction. So since F and D are in opposite directions, that means that she's doing negative work. Or you can think of it also as since she is slowing the ball down, that means it's taking energy away. If I'm taking energy away, that is very clearly a negative work. Okay, work requires both a force and displacement. Work is equal to F times D. A soccer player kicks a ball up into the air. Describe the transition of energy for the ball after the ball leaves a player's foot, goes up in the air, and returns to the ground. So I have this ball, it goes up and comes back down again. Up here it has potential energy, down here has kinetic energy, and down here again has kinetic energy. So I'm going from kinetic to potential to kinetic. Which of these is a unit for work? Joule is a unit for work, calorie is a unit for work, and Newton meter is a unit for work. Watts is not. Watts is a work per unit time. So I'm looking at 1, 2, and 3. Which of these best describes heat? Heat is the transfer of thermal energy. So it's not the same as thermal energy, it's the transfer of thermal energy. While it does result in an increase in temperature, if I gain heat, that's not what heat is. While it can be a rise in potential energy, that's not heat. And while it can be this, that's not really, like it can result in the storing of energy, that the heat is the transfer of thermal energy. At what location does the cart have the highest speed? That is, where does it have the most kinetic energy? And that's going to occur at the lowest point. That's where the potential energy is at its smallest and the kinetic energy is at its biggest. So B is the right answer. Where does the object have the most potential energy? That's going to be up here. Remember, potential energy is equal to mgh. So wherever h is biggest, that's where you're going to have the most potential energy. You push a cart with a force of 10 newtons over a distance of 5 meters. By how much have you increased the energy of the cart? You've increased the kinetic energy by the same amount that you've done work. And you're applying a force of 10 newtons over 5 meters. So you've increased it by 50 newton meters or 50 joules. Chemical energy arises from that's energy between molecular bonds. Whoops. Which of these best describes a closed system? That no energy enters or leaves the system. Remember, we talked about a closed system too before, actually, in our chapter on fluids, and we can also think about this no energy or matter enters or leaves the system. But now we're talking about energy, we talk about energy. Okay, so which of these is a nutrient? So a lipid is a nutrient. That's just a fancy way to say a fat, a carbohydrate, a protein, vitamins and minerals, and water. All of these are nutrients. Which of these has the highest energy density? That's going to be our lipids, or our fats have the highest energy density by quite a lot. Carbohydrates are derived mainly from plant-based products. The body is about 20% efficient in converting energy from food into usable work. Then if you consume 100 calories of food, how much physical work will you be able to perform? Well, if I'm 20% efficient, that means 20% of my energy is used, then I'm looking for 20% of 100 calories. And remember, 20% is the same as 1/5, 20 over 100. And what's 1/5 of 100 is going to be 20 calories. So number 14 is D. What is BMR? That's our basal metabolic rate. Our basal metabolic rate is the rate at which body converts energy into heat while resting. It's sort of just how much energy does it take for your body just to live? This is the total metabolic rate, and then this is your active, what the energy that's used in exercise. What is the primary means by which the body loses thermal energy? Remember, we're all like infrared light bulbs, radiation. Then, which of these is the way a body responds when it was cold and needs to be warming? Needs to be warmer. Let's see. So you would shiver. That would warm up your body. This would, if you're warm and need to be cold, then you would do that. So that's not it. And then dilation of the blood vessels. That's if you're uh, warm and you want to release heat. then your blood vessels will open up, blood will rush to the skin, and then that will allow you to get hot, allow you to get rid of that heat. That's why, when you're really hot, your skin turns red because that blood's all rushing up to the skin to release heat from the body. So it's not that, and it's not decreased rate of blood flow, so it's going to be D. Which of these is the typical BMR for a person? It's about 1500. Some people might have a higher BMR than that. Like my basal metabolic rate is really more like 2000 to 2500. But the typical person is going to be about 1,500 calories per day. Consider these materials listed with their specific and latent heats. Update, use the data, answer the following set of questions. Which material requires more energy to increase its temperature? The one with the highest specific heat will require more energy, so that's going to be water, A. When the materials are at their melting points, which material will require more energy to go from solid to liquid phases? So when I'm talking about solid to liquid phases, that's talking about fusion. And the one that requires the most energy to go from solid to liquid is going to be the one with the highest latent heat of fusion. So again is water. Um, One of these is also called the latent heat of melting. That would be the latent heat of fusion, going from a solid to a liquid, or from a liquid to a solid. Convection is a method of heat flow. What does it require? It requires movement of a fluid. This would be conduction. Evaporation is sort of conduction, also sort of kinda. And then emitting of light, that would be radiation. Not rad, but radiation. Pieces of metal and plastic are in the same room. The room has a constant temperature. Which statement about them is true? If they're in the same room and the room has a constant temperature, that means that they're going to be in thermal equilibrium with the room and in thermal equilibrium with one another. So the plastic and the metal have the same temperature. However, one of them feels warmer and one of them feels cooler. The metal will feel cooler because it has a higher thermal conductivity. Remember, we did this where we had the two blocks, and one of them, even though they were the same temperature, the metal one felt a lot cooler because it had a higher rate of thermal conductivity. The following describes thermal conduction. The thermal conduction through a material is 2 kilocalories per second. If I change that material and now have twice the thermal conductivity, what is the new rate? So if I double this, that means that this has to be doubled. So Q over T was 2 kilocalories per second, so now it needs to be 4. The temperature of the human body in degrees Celsius is about 40 degrees Celsius. 37 in particular, is more specifically. Select the true statements. It's possible to have liquid water at 0 degrees Celsius. Okay, yes. Steam can exist at 120 degrees Celsius. In fact, yes. So the freezing point of water is 0. The boiling point is 100 degrees Celsius. But I can have liquid water at 0. Remember, I have to get rid of that latent heat of fusion in order to change it into ice. This is not true. The freezing point of water is not 0 Kelvin. 0 Kelvin is actually absolute 0. Theoretical temperature, the lowest temperature attainable, and is the point at which all motion stops. Which of these may result in hearing loss? You can have earwax, you can have middle ear infection, loss of hearing, all of these. The speed of sound is around 760 miles per hour. What are the speeds of sound in water and steel? So in air should be the lowest, and then water should be the next highest, and then steel should be the highest of all. As I move from a gas to a liquid to a solid, my speed of sound will increase. So I have 760, get rid of those, to 3400 to 11400. I don't include A because it actually decreases as I move from liquid to solid. You stand 1 meter from a point source of sound and the intensity is I. If I move a half a meter closer, then what happens? So remember that I is proportional to 1 over R squared. And so if I move a half a meter closer, that is, I'm decreasing this by a factor of a half. Because it's squared, that means I'm going to have an increase of 4 in I. So this diagram, which of these is called the cochlea? That would be 6. Which part commonly becomes blocked when you have an ear infection? That's number 5. It's your eustachian tube. Which part has a shape that helps collect sounds at certain frequencies? That would be your outer earlobe, number 1. Which of these is part of the middle ear, 2, 4, 6, or 7? Well, it's not 2, that's part of the outer ear, and it's not 6, that's part of the inner ear, and likewise 7, so it has to be 4, that's our tympanic membrane, our eardrum. That is part of the middle ear, by the way. Your middle ear starts at the tympanic membrane. The ossicles serve this purpose. Remember, those are the 3 bones, and they convert they increase the force from the eardrum onto the cochlea. True or false? The microphone and speaker operate by the same mechanism. That is true. They both operate very similarly. Number 36 is 100 dB is how many times as intense as 80 dB? It is 100 times more intense. A good way to look at this is 100 minus 80 is equal to 20. Okay? Uh, Drop the 0, take the first number. I am going to be 10 to the second. That's where that number went, right here. 10 to the second, or 100 times more intense. It's a logarithmic scale, so a small increase changes it by a lot. Which of these statements is true? Pitch is associated with a wave's frequency, or volume is associated with a wave's amplitude. Both of those things are true. Pitch is associated with the frequency and volume with the amplitude. A vibrating string produces a sound of a certain frequency. What happens with the frequency? The mass of the string is increased. Number 38, that's going to be B. You think about a guitar, the strings at the top, the low strings are the really big strings. They have a greater mass or a greater mass density. You have a guitar, which of these can you do to make a sound have a lower pitch? You can increase the length of the string or increase the mass of the string. If you increase the tension in the string, that makes the frequency go up. So 2 and 3 is right. The pitch of an individual's voice is modulated by changing the tension of the vocal cords. What part is labeled 2? That's their trachea. Noise-canceling headphones operate because of the interference of sound waves. Ultrasound machines measure the time for sound waves to travel. That's D. Bernoulli principle states that when the velocity of a fluid increases, the pressure decreases. Remember, we saw this in the previous chapter, but our pressure decreases. Ultrasound equipment can operate at which of these frequencies? Very high frequencies, so 10 million hertz. The speed of a wave is dependent upon its medium. Remember, even though the speed of a wave is equal to the frequency times a wavelength, it's constant. It doesn't, if this goes up, nothing happens to the speed of the wave. Instead, the wavelength will go down. The way that you change the speed of a wave is put it in a different medium. Which of these shows the wavelength? All right, so wavelength is one full cycle. So it goes from that first line all the way over to C. Transverse waves cause the medium to move up and down. A blank wave is a what? So is a pressure wave a longitudinal wave? Yeah, I think so. Let's go ahead and pick that. But let's look at these others. A water wave is not longitudinal. It's transverse. It moves up and down, not side to side. And a sound wave is not a transverse wave. It is a longitudinal wave. So A is the right answer. For an object in simple harmonic motion, if you increase the displacement from the equilibrium position, the restoring force will increase. That is that the force is proportional to delta x. That's called a restoring force. Which has a bigger spring constant? The springs on your car, because F is equal to kx. The one that gives the bigger force is the one that has the bigger spring constant. And a slinky and Tigger's bottom are both not real big forces compared to your car. The velocity of a wave is 2 meters per second. Its period is 2 seconds. What is the wavelength of the wave? Well, I gave this before. V is equal to frequency times wavelength. So if this is 2 meters per second, the frequency is that, and this is 2 seconds, then, I'm sorry, no, I'm sorry, did it wrong there. So here, I give here the period. So I can say V is equal to F lambda, and I can figure out what is F. It's going to be V over lambda. So that's going to be 2 meters per second over 2 seconds. So the frequency, excuse me, 2 meters per second over 2 meters is going to be 1 inverse second, or 1 hertz. So my frequency is 1 hertz, but my frequency is also equal to 1 over the period. No, I'm sorry, y'all. I'm sorry. Let me start over here. I was getting this all mixed up. Um, okay, sorry about this. Try to go too fast. It doesn't work so well for us, does it? All right, so the velocity of the wave is 2 meters per second. V is 2 meters per second. The period is 2 seconds. And I want to know what is the wavelength. All right, well, if the period is 2 seconds, that tells me that the frequency is 1 over t, or 1/2 second. And then I know that v is equal to frequency times wavelength. That's 2 meters per second is equal to the frequency, which is a half of a hertz. And actually, this should be half seconds to the -1, or half of a hertz, times my wavelength. That means my wavelength is 4 meters. So A is not the right answer. C is the right answer. What is the frequency of the wave? Look, I already got that right here. It's a half a hertz. And then who is the favorite student? I like Anna Leska a lot, and John Boudreau, and Olivia Gautreaux, but you're my favorite student.